A very good morning to all my dear students. Welcome back to our online mathematics class. Today we are going to discuss about in our irrational numbers. First topic is representing irrational numbers on number line. Next one, find irrational numbers between any two rationals. Find irrational numbers between any two rationals. And simplification of irrational numbers by using algebraic identities. Simplification of irrational numbers by using algebraic identities. Let's get into the topic. First one, representing irrational numbers on number line. We already know how to identify rationals on the number line. So this is representing irrational numbers on the number line. So example 7, this is our first question. Locate root 2 on number line. Locate root 2 on number line. So first one, locate root 2 on number line. So draw a number line. This is our number line. So let's take 1 unit measure. So 0, 1, 2, 3, -1, -2. So we already know in our previous cases how to identify rational numbers on the number line. So this is irrational number. Locate root 2 on the number line. So let's take 1 unit of measure. So here A to B. A to B. The distance between the A to B is 1 unit measure. So draw a perpendicular of AB at B. Draw a perpendicular of AB at B. So you can draw perpendicular by using protractor also. I can try with compass. So angle bisector of 60, 120 is 90, right? This is 90 degrees. So 1 unit measure. 1 unit measure. So this is the 1 unit measure. The intersecting point is called C. So join AC. Join AC. So the distance between the A to C is root 2 units, right? The distance between the A to C is root 2 units. So BC is also 1 unit. AB is 1 unit. BC is 1 unit. The diagonal AC is root 2 units. Take a measure of AC. So with point A, draw an arc from C to number line. C to number line. This arc will touches the number line at K. So the distance between the A to K is root 2 units. Root 2 units. The distance between the A to K is root 2 units. This point is called, this K is called root 2. Right? So our problem is locate root 2 on number line. So this K value is called root 2. So the distance between the A to K is root 2 units. So next one, example 8. locate root 3 on number line. Next our question is locate root 3 on number line. Locate root 3 on number line. This is our next question. Draw our number line. Next, A to B is 1 unit. So perpendicular line measure is also 1 unit. Let's draw perpendicular line. You can draw with protractor also. So perpendicular line. Let's take 1 unit of measure. This is 1 unit, right? So this is 1 unit. A to B is 1 unit. So B to C is also 1 unit. Distance is 1 unit. So join AC. Join AC. So root 2 units. This distance is the measure of root 2 units, right? So draw a perpendicular of root 2. That means draw a perpendicular of AC at C. So draw a perpendicular of AC at C. So this line is the perpendicular of AC, not AB. This line is the perpendicular of AC. Right? So let's take 1 unit length. Let's take 1 unit length. So this is 1 unit. So this point is called D. Join AD. Join AD. So with center A, measure AD. Let's take measure AD with center A. Draw an arc. This arc will intersect this line at this point. This point is called K. So this intersecting point is called root 3. The distance between the A to K is root 3 units. This point is called root 3. So here our question, locate root 3 on number line, right? So the distance between the A to K is root 3 units. This point K is called root 3. This is the location of root 3 on the number line. This is the way we can identify any irrational number on the number line. This is the procedure for identify the irrational number on the number line. Next question, find any two irrational numbers between 1/5 and 2/7. Find any two irrational numbers between 1/5 and 2/7. So find any two irrational numbers between 1/5 and 2/7. So here the decimal form of 1/5 is 0.2, right? The decimal form of 1/5 is 0.2, and 2/7 is, we already know the decimal form of 2/7 is 0.285714. 285714. This is the decimal form of 2/7. This is the decimal form of 1/5. This is terminating decimal expansion. This is non-terminating repeating decimal expansion. This is terminating. This is recurring. So find any two irrational numbers between 1/5 and 2/7. These both are rational numbers, right? So rational numbers decimal form is in the form of either in the form of terminating or recurring. So irrational numbers decimal expansion is neither terminating, non-recurring, neither terminating, non-recurring. So 0.20, the irrational numbers between 0.20 and 0.28. 28 is enough. So 0.20 and 0.28. So the irrational numbers decimal expansion is neither terminating, non-recurring, right? This is irrespective decimal forms continuously goes on. So 0.2, 17, 24, 56, 25, 27, so and so on. This is the one of the irrational number is in between 1 by 5 and 2 by 7, and again 0.24, 54, 64, 11, 24, 11, and so on. These are two irrational numbers is in between 1 by 5 and 2 by 7. Next our question is find an irrational number between 3 and 4. So the irrational number between any two rationals is square root of a into b. The rational number is in between two rationals is a plus b by 2. Here our formula in irrational numbers, our formula is square root of a into b. So example 10, our question is find an irrational number between 3 and 4. Our formula becomes square root of a into b. Here a is equals to 3, b is equals to 4. So the irrational number is in between 3 and 4 is square root of 3 into 4, a into b, 3 into 4. So that is equals to square root of 12. So this is the irrational number is in between 3 and 4. 3 and 4 irrational number is in between irrational number is square root of 12, or square root of 12 can be written as a square root of 4 means 2 into root 3, right? So that can be written as 3, 2 into root 3, comma 4. The irrational number is in between 3 and 4 is 2 into root 3. Next, again the irrational number is in between 3 and 2 root 3 is square root of a into b. Our formula is, so here a is equals to 3 into b is equals to 2 into root 3 square root of, here 3 2s are 6 into root 3 square root of. So here irrational number is in between 3 and 2 into root 3 is square root of 6 into root 3. 3 comma square root of 6 into root 3 comma 2 into root 3 comma 4. So the irrational numbers is in between 3 and 4 is square root of 6 into root 3, 2 into root 3. Okay, my dear students, by using this formula we can find out any irrational numbers between two rationals. The formula is square root of a into b. Our formula is square root of a into b. This is in between irrational numbers formula. So a plus b by 2 is in between rational numbers formula. Okay, right. Next. So here our next question is examine given following numbers are rational or irrational. Our first question is 3 plus root 3 plus 3 minus root 3. So that is equals to 3 plus root 3 plus into plus 3 plus into minus root 3. Here plus root 3 minus root 3. Both are cancelled. So 3 plus 3 is equals to 6. Result is it is a rational number, right? Rational number. It is a rational number. Next question. So 3 plus root 3 into 3 minus root 3. 3 plus root 3 into 3 minus root 3. 3 plus root 3 into 3 minus root 3. Next question. So it is of the form a plus b into a minus b, right? It is of the form a plus b into a minus b. So our result is a plus b into a minus b. Result is a square minus b square. By using algebraic identities, a plus b into a minus b result is a square minus b square. Here a is equals to, compare with our formula, here a is equals to 3, b is equals to root 3. So substitute these values in our formula. So that is equals to a square means 3 square minus b square means root 3 whole square. Here square root cancel, 3 square means 9 minus here 3, result is 6. It is also a rational number. It is also a rational number. Next question, 10 by 2 root 5. 10 by 2 root 5. So here 2, denominator 2, numerator is 10. So 2 5 times 10, right? So that is equals to 5 by root 5. So here rationalize numerator and denominator with root 5. Rationalize numerator and denominator with root 5. Here denominator is root 5. Rationalize numerator and denominator with root 5. So that is equals to, here root 5 into root 5, that means root 5 whole square. So that is equals to 5. Here root 5 into root 5 is equals to root 5 whole square. So that is equals to 5. Here denominator is 5. Numerator is 5 into root 5. Here 5 cancel, result is root 5. It is not a perfect square, right? It is not a perfect square. So it is an irrational number, an irrational. Next one, fourth one. So root 2 plus 2 whole square. Root 2 plus 2 whole square. So it is of the form a plus b whole square. By using our algebraic identities, it is of the form a plus b whole square. So result is a square plus b square plus 2ab. Here a is equals to root 2, b is equals to 2. Here a is equals to root 2 whole square, b is equals to 2 square, plus 2 into a into b means 2 into root 2 into b means 2. 2 into root 2 into 2. So here square root cancel. So 2 plus 2 2s are 4. 2 square means 2 2s are 4. 2 2s are, here is also 4 root 2. Here 4 plus 2 is equals to 6 plus 4 root 2. So it is an irrational number, right? It is an irrational number. So first one is the rational, next one is the rational, next one it is an irrational, and fourth one is also irrational number. Next one, exercise 1.2. So classify following the numbers are rational or irrational. So classify following numbers are rational or irrational. This is root 27. This is root 27 means square root of square root of 9 into 3. So that is equals to here 9. Square root of 9 is 3 into root 3, right? So it is an irrational number. First one is an irrational number. So here second one as your homework, and third one 30.232342 So it is a, the decimal expansion is neither terminating non-recurring. The decimal expansion is neither terminating non-recurring. So it is a irrespective decimal forms, continuously goes on. It is an irrational number. It is an irrational number. The decimal expansion is neither terminating non-recurring. Next one here 7.484848 and so on. Here repeating decimals are 48, right? Here repeating decimals are 48. So it can be also write it as 7.48 bar. It is recurring decimal expansion. It is a rational number. Rational number. Next one, fifth one. So 11.2132435465. So it is a terminating decimal expansion. It is a terminating decimal expansion. So it is a terminating decimal expansion. Next one, sixth one, 0.30300 So it is neither terminating non-recurring and continuously goes on, right? So on. Look here, it is a continuously goes on. So it is neither terminating non-recurring. So it is an irrational number. Next one, give 4 examples of rational and irrational numbers. This is as your homework. Next one, find an irrational number between 5/7 and 7/9. How many more there may be? So it is infinity number of irrationals is in between 5/7 and 7/9. So this example, this third one is similar to our ninth one. So this question is similar to ninth example. So there are infinity number of irrationals is in between 5/7 and 7/9. Next one, find two irrational numbers between 0.7 and 0.77. This is also similar to our example 9. So these two questions are already clear, right? Next one, seventh one, locate root 10 on number line. Locate root 10 on number line. So this one is related to our first question, representing irrational numbers on the number line. This is similar to example 7 and 8. Locate root 2 on number line. Our question is here, locate root 10 on number line. Next, find at least two irrational numbers is in between 2 and 3. Find at least two irrational numbers is in between 2 and 3. So this question is similar to our example 10. Find an irrational number is in between 3 and 4. This question is similar to example 10. Eighth one is similar to example 10. Next one, ninth question. State whether the following statements are true or false. Justify your answer. First question, every irrational number is a real number. Every irrational number is a real number. Yes, it is true. Every rational number is a real number. It is also true. Every rational number is a real number. Real numbers are the combination of rationals and irrationals. Real numbers are the combination of rationals and irrationals. Every irrational number is a real number. Every irrational is a real number. Every rational is a real number. Every real number need not to be rational. Every real number is need not to be rational. Yes, it is also true. Need not to be rational. So real numbers means rationals plus irrationals. Every real number is need not to be rational. Next question, root n is not an irrational number if n is a perfect square. Next one, root n is irrational number if n is not a perfect square. Last question, all real numbers are irrationals. These three as your homework. So exercise 1.2 as your homework. If you have any doubts in this session, please contact my number. Thank you. Have a nice day.